You know, most of the universe isn't actually made of anything you can see, touch, or even really imagine. So this number, 5%, what is that? Well, that's everything we thought the universe was. It's the entire visible cosmos.
I mean, that's every star, every planet, every single galaxy. It's you, me, the screen you're looking at. All of it is just this tiny, tiny fraction of what's really out there. Kind of like the tip of a cosmic iceberg.
Because, well, this is the rest. 95% of the cosmos is made of something else. And what that something is, that's the ultimate mystery.
And so today, we're going on a hunt for this cosmic ghost, this strange, elusive stuff that we call dark matter.
Okay, so let's get right into it. Think of this whole thing like a cosmic detective story, right? The universe is our crime scene and the numbers, they just don't add up.
Here's the deal. For every one part of ordinary matter, the stuff that makes up us and everything we know, there are 5 parts of this other invisible stuff. It's like the universe's silent, unseen majority.
So you might be asking, how do we even know it's there? Well, astronomers kept seeing things that just broke the laws of physics as we know them. They saw galaxies spinning so fast they should have just flown apart. They saw whole clusters of galaxies that weighed way more than they should have. And they even saw light bending around patches of space that looked completely empty.
And all these bizarre clues point to one culprit: dark matter. See, it's this invisible form of matter that doesn't mess with light at all. It doesn't emit it, doesn't reflect it, but it does have gravity. In fact, you could say it's the gravitational glue that's holding our entire universe together.
So where did this whole investigation start? Well, it all kicked off with a really persistent astronomer named Vera Rubin and the strange pace of these spinning galaxies.
Okay, so on the left is what everybody expected to see. Based on all the visible stuff, stars on the outer edge of a galaxy should be moving pretty slowly, kind of like the outer planets in our solar system. But what Vera Rubin actually saw, what you see on the right, was just shocking. The stars way out on the edge were moving just as fast as the stars right in the center.
And this really gets to the heart of the problem. I mean, the physics was totally clear. Without some extra mass providing a ton more gravity, these galaxies should be ripping themselves to shreds. They're just spinning way, way too fast to hold together.
And suddenly, the conclusion was inescapable. There had to be something else. Each galaxy must be sitting inside a vast, invisible halo of dark matter, and that's what's providing the extra gravitational pull needed to keep everything from flying apart.
But hey, one piece of evidence isn't enough to make a conviction, right? So let's turn to a completely separate, independent observation that basically confirms something massive was hiding out there in the dark.
And this gets into a phenomenon called gravitational lensing. Basically, Einstein's theory of relativity says that really massive objects actually warp space-time around them. And this curvature can bend the path of light, kind of like a giant cosmic magnifying glass.
And what's so cool is you're seeing that exact effect in action. The bright yellow spots, that's a cluster of galaxies. But look at those weird blue arcs. Those aren't real shapes. That's the distorted, kind of funhouse mirror image of a single galaxy way, way behind the cluster. Its light got bent and smeared out by the incredible gravity of the cluster in front. And by measuring that distortion, we can weigh the cluster. And guess what? It's way heavier than all its visible stars and gas can account for.
And this is the smoking gun. What you're looking at is the aftermath of 2 huge galaxy clusters that smashed into each other. The normal matter, which is mostly hot gas, shown here in pink, it all collided and slowed way down. But the map of where the gravity is, shown in blue, it tells a different story. Most of the mass just passed right through the collision, like it wasn't even there. This is as close to direct proof as we have that most of the mass out there is some kind of invisible, non-interacting substance.
So, okay, the evidence is pretty overwhelming. But the big question remains, what is this stuff? So now our cosmic detective story moves into the next phase. We've got to identify the culprit. Let's look at the lineup of suspects.
All right, first, let's rule out all the usual suspects. It's not dim stars or rogue planets or big clouds of gas and dust. We'd have spotted those by now. It's not a bajillion black holes floating around, and this is the big one, it is not any of the particles we know about in the standard model of particle physics. It has to be something totally new. This leaves us with a few top candidates from the wild world of theoretical physics. First, you've got WIMPs. That stands for weakly interacting massive particles. Think heavy and slow-moving. Then you have axions, which are these hypothetical, incredibly lightweight particles. And finally, sterile neutrinos, which are like these ghost-like cousins of the neutrinos we already know. They each have a compelling story, but for now, they're all just suspects.
And you know, this theoretical mystery has launched a very real, globe-spanning manhunt to try and catch just a single particle of dark matter in the act.
I mean, scientists have built some of the most sensitive experiments you can possibly imagine. They've gone deep underground in old mines just to shield their detectors from all the background radiation. They're using these huge vats of liquid xenon, basically just hoping one dark matter particle will bump into one single nucleus. They're building things called haloscopes to listen for the tiniest whisper of an axion. Even the huge particle colliders at CERN are keeping an eye out.
And after all that, decades of searching, hundreds of millions of dollars, the result has been absolute silence. Nothing. The ghost remains a ghost.
Now, this long silence has led some physicists to start asking a pretty radical question. What if we've been chasing a ghost that isn't even there? What if the problem isn't some missing matter, but a flaw in our understanding of gravity itself? And this brings us to the two big camps in this debate. On one side, you have the standard dark matter theory. There's a new particle out there, and our laws of gravity are fine. But on the other side, you've got theories like MOND, or modified Newtonian dynamics. They say, nope, no new particle needed, we just have to tweak the laws of gravity when we're talking about the huge scales between galaxies. It's a really fascinating question. Do we add new stuff to the universe, or do we change the rules?
So where does this leave us in our cosmic detective story? Well, the trail hasn't gone cold, but the mystery is definitely deeper than ever. Is dark matter a new fundamental particle just waiting for us to find it? Is it some kind of hidden field that fills all of space? Or is it a warning sign that our most fundamental theory of gravity is just incomplete?
We just don't have the answer yet. But one thing is absolutely certain. Cracking the dark matter mystery isn't just going to solve one little problem. It's going to light up a whole new universe of physics and completely change our picture of reality itself. And honestly, that's a discovery worth waiting for.